Okay, so let's look at the problem 8.31, which relates to the Gay-Lussac law. And here we are given a problem 8.31, calculate the final temperature in degrees Celsius for each of the following if the number of moles and the volumes do not change. So we are given the temperature, initial temperature 25 degrees Celsius, at which the pressure of the gas is 740 millimeters of mercury. So when it is cooled, the pressure is 620 millimeters of mercury. And the question is, what is the final temperature? And we need to calculate the temperature in degree Celsius. Okay, so let's write this problem. Okay, so here we have written the problem, and now let's solve it. So since the volume and the number of moles is constant, means they are not changing. So we know the formula is P1 over T1 is equal to P2 over T2. And that is the Gay-Lussac law. Now, here, since we need to find the temperature, so we have to do the algebraic conversions. So back here, P1 over T1 times T2, make it a, a numerator. Here P2 over T2 times T2. And here you are going to, T2 and T2 gets cancelled. But we need to find the T2. So here P1 over T1, okay, P1 over T1 times T2. And then here it's also T1, because we need to cancel this from here, P1 times is equal to P2 times T1 over P1. Okay, so this is canceling out the P1 and T1 from one side of the equation, and it brings it on the other side. Okay, now here we have this new formula now, which is T2 is equal to P2 times T1 over P1. Okay, now we need to equalize equalize. So this is millimeters of mercury. Sorry, this should be Hg. This is millimeters of mercury, and the other one is also millimeters of mercury, which is fine. And you should get into the habit of converting the degree Celsius to Kelvin. Okay, so 25 degrees Celsius plus 273, and that is equal to 273 273 plus 25, and that is equal to 298 K. And we will reconvert it back. So this becomes 298 K. Okay. Now let's plug in the numbers. P2 is 620 millimeters of mercury, 620 millimeters of mercury. Okay, millimeters of mercury times T1. T1 is 298 K, 298 K over P1, which is 620 over P1 is 740 millimeters of mercury. So you see here, this gives you the temperature T2 in Kelvin. And you are going to see that the millimeters of mercury and millimeters of mercury cancel out. So 620 times 298, divide that by 740, and this gives you 249. The answer here is 249.67, 249.67 Kelvin. Okay, but the question has to be in, this is T2, but they want this Kelvin needs to be converted to degrees Celsius. So here we see that in this case, we are going to take 249.67 Kelvin, minus 273, and that will be 0.67 minus 273, and that is 23.32. Okay, so this is equal to, and this will be a negative number, 23.32 degrees Celsius. Let's put it here, degrees Celsius. So this is the value of T2 is equal to 249.67 You can also do 250, that's fine. So sorry. 249.67 minus 273, and that is 23.32, but negative 23.32 degrees Celsius. Okay, and that is the answer. All right, so that's the value of the final temperature. So here, remember that when the temperature goes up, the pressure also goes up, because temperature and pressure are directly related. Okay, so we see here that so you can check your answer also. So 298 K, and here we got 249 K. Okay, so this is technically 249.67 K and 23 negative. This is 23.32 degrees Celsius. Okay, so either way, so 298 K versus 249 K. Okay, so this is a smaller number. And similarly, you look at the pressure. So pressure is 740 and 740 millimeters of mercury. So the pressure has gone down. Pressure went down, the temperature went down. Pressure went up, the temperature also went up. So that's the right answer. Okay, so that was 8.31. Next, we are going to look at the problem 35. And 35 relates to the combined gas law. So hang in for a minute. Okay, so here 8.35, a sample of the helium gas has a volume of 6.50 liters at a pressure of 845 millimeters of mercury and a temperature of 25 degrees Celsius. What is the final pressure of the gas in atmosphere? When? So final pressure of the gas in atmosphere. When the volume and the temperature of the gas samples are changed to the following if the amount of gas does not change. So I'm going to look at only question part A. Okay, so here I have written it down, and we have the final like the volume and the temperature also, which is the volume is 1850 and the pressure is, and the temperature is 325 K. Okay, so let's solve this. So give me a minute. Okay, so here I have written this. So now here, pay attention to a few things. Number one, you are given the pressure in millimeters of mercury, and they're asking you in ATM. So there's one conversion we need to do. So we're going to convert the millimeters of mercury to ATM. So we get the final answer in ATM. Next thing, you're given in degrees Celsius, that's temperature 1, and you're already given the Kelvin in another one. So that one we won't change. We need to change the degrees Celsius to Kelvin. Next is you're given liters here, and you're going to convert to milliliters. So let's do these conversions first. Number one, V1. So we need in liters. So liters is a liter. Liter is a unit that, you know, it's a standard. So keep it. But this one, you need to convert it into liters. Once again, millimeters of mercury and ATM, both of them are standard, but the answer is an ATM. So therefore, this one needs to be converted to ATM. And then Kelvin, and then so this one needs to be converted to Kelvin. So let's do these now. So number one is 1.8. So that is V2, the value of V2. V2 is 1850 milliliters. And then convert that to liters. So we know that 1 liter is equal to 1000 milliliters. Okay, so what will you do here? When 1 liter over 1000 milliliter, that is the conversion factor. So 1850 milliliters times 1 liter over 1000 milliliters. So you cancel this out. Milliliters and milliliters cancel out. So this becomes 1.850 liters. Okay. So that's the V2. Okay, V2. Next is the next conversion is the 845 millimeters. So that's now we have P1. P1 is equal to 845 millimeters of mercury. Okay, convert that to ATM. Now here we have 8. So we know that 1 ATM is equal to how many millimeters of mercury? So get that. Okay, so it's 1 ATM is 760 millimeters of mercury. So we can create conversion factors from there. So 845 millimeters of mercury times 1 ATM over 760 millimeters of mercury. So if you look at it, the millimeters of mercury and millimeters of mercury cancel out. So all you have to do is 845 times 1 divided by 760. So 845 times 1 divided by 760, and you get 1.11. So this is equal to 1.11. Let's put this in a different, sorry. So it's 1.11 ATM. Okay, ATM. All right. Next is the last one, the T1. So this is the value of, this was the value of V2. This was the value of P1. And then we have the third one, which is the T1. T1 is 25 degrees Celsius. Okay, so 25 degrees Celsius, convert that to Kelvin. So we're going to take 25 degrees Celsius plus 273, and that gives you the Kelvin. So 25 plus 273, and you have 298 Kelvin. Okay, now we need it for P2. So the kind of formula we are going to use here is this combined P1 V1 over T1 is equal to P2 V2 over T2. All right, now we need to find for P2. So we are going to remove the V2 and T2 from one side of the equation. So how do we do this? P1 V1 over T1 times T2 over V2 is equal to P2 into V2 over T2 times T2 over V2. So cancel here T2 and V2, and you're just left with the P2. Okay, so now we're going to just put in these numbers. So P1 is 845 millimeters of mercury was converted to 1.11 ATM. So 1.11 ATM times V1. V1 is 1.850 liters. 1.850 liters, and sorry, over T1. T1 is 298 K. So this one was equal to T1, 298 K over 298 K times T2 over V2. T2 is 325 K, 325 K over V2. V2 is 1850 becomes 1.850 liters. And that is equal to, this whole thing is coming out to be equal to P2. Okay, so how, if you look at it, that K and K cancel out, liters and liters cancel out. You're just left with the unit in ATM. But let's look at these values now. So we have here 1.11 times 1.850 times 325. Okay, this gives you 667.38. 667.38. Okay, divide by, so here you have 298 times 1.50. 298, 1 second, 298 times 1.850. And you have 551. Divide by 551. Okay. Now, 667.38 divide by 551. And you get 1.21 P2, and that is the value in ATM. Okay, so let's just check it. So 8.35, no? So hold on. Okay, guys, so this volume was 6.50. Okay, so I made a computation error. So instead of using 6.50, I took 1.85. So please make sure that you put the correct V1 value, which is 6.50 and not 1.85. But anyways, so when you do the multiplication, 1.11, 3 significant figures, times 6.50, 3 significant figures, times 325, and you get 2344.87. Next, 298 times 1.850 is going to give you 551.34. But remember that, remember that your answer should have 3 significant figures, because 1.11 and 6.50 are 3 significant figures. So we look at the lowest, significant figures in the answer when we are multiplying or dividing. So here you see that you get the answer 425 ATM, and that's the right answer. Okay, so now we are going to stop here and we're going to look at the other questions in the next video. All right, thank you for watching. Bye-bye.